Hello, welcome again. We are solving Mechanical Engineering Paper 2 of year 2025 of IFS Mains exam. Question number 6b is dry saturated ammonia is compressed in a reciprocating compressor from saturation pressure at minus 10 degrees Celsius to saturation pressure at 40 degrees Celsius. The compressor has 4 cylinders each with a bore of 10 cm and a stroke of 8 cm. Clearance volume ratio is 0.04 and it runs at 750 rpm. Find 1 volumetric efficiency assuming isentropic compression, 2 the swept volume flow rate, 3 the mass flow rate, and 4 refrigeration capacity. So use saturation and superheat tables for NH3 given below. So these tables are given. This is saturation table and this is superheat table at 15.155 bar. Okay. So this is the given vapor compression cycle on TS diagram. 1, 2 is your compression process, and so it is compressor, and we know that volumetric efficiency of compressor is 1 plus K minus K P2 by P1 divided per 1 by N, where N is your polytropic exponent. Here the polytropic exponent is your gamma because it is isentropic process, and K is your clearance volume ratio. Okay. So now we have to find out this N because we have P2 and we have P1. P2 is pressure at saturation pressure at minus 10 degrees Celsius, and this pressure, and P2 is pressure at 40 degrees Celsius, and P1 is pressure at minus 10 degrees Celsius. Okay. So here P2 and P1 are not, K is not, K is 0.004, but we don't know N, so we need to find out N. And entropy at 1 is corresponding to saturation condition, so that is 5.4716, okay, minus 10 degrees. And entropy at 2 will be equal to entropy at 1 because it is an isentropic process. Okay. And this is your superheated part, and we have at 60 degrees Celsius and 80 degrees Celsius the entropy value. Okay, that is 5.3883 and 5.5253. So by using interpolation we can find out this temperature T2. That is 5.5253 minus 5.3883 divided by 80 minus 60 is equal to 5.5253 minus 5.4712 divided by 80 minus T2, and T2 will come out as 72.102 degrees Celsius, and T1 will be your minus, T1 is your minus 10 degrees Celsius, T2 is this. So now as this is your isentropic process, or you can say polytropic process, or the isentropic relation is P2 by P1 is equal to T2 by T1 raised for n by n minus 1. P2 is known, P1 is known, T2 is known, T1 is known. So just we need to find out N. So that can be found out by taking ln both sides. So ln value of this is your 1.6765, and for this it is 0.27168. So from this N will come out as 1.19 or 1.24. Now we have N value also, and we have this P2 and P1 also. So we can find out volumetric efficiency. That will be 87.67%. Next part is to find out volume, swept volume flow rate. So as diameter is given, stroke length is given, so that is your volume. Number of cylinders are 4, so that is 4. So that is your swept volume per stroke. So as 750 rpm is given, so if you multiply by 750, then it will be swept volume per minute. If you divide by 60, then it will be swept volume per second. Okay, so that is your 1.256 meter cube per second. Okay, and actual volume flow rate will be your swept volume into volumetric efficiency, that will be your 1.1 meter cube per second. Okay, now we have to find out mass flow rate, and another value that we can see from the table is your Vg at minus 10 degrees Celsius or at point 1, at point 1. Okay, so that is your 0.418, and this is your volume flow rate. It will uh, divided by specific volume, then it will be mass rate, that is 2.633 kilogram per second. Okay, and the refrigeration capacity is mass flow rate into change in enthalpy. So that is your H1 minus H2, H4. So H1, this is mass flow rate, and H1 is your H1 is corresponding to this point. This point is saturated vapor enthalpy at minus 10. So that is your 1431.409, and in vapor compression cycle H3 is equal to H4. So and H3 is your enthalpy of saturated liquid at 40 degrees Celsius. So this is your 40 degrees Celsius. That is your 371.4. Okay, so it will come out as 2790 kilowatt. That is the mass into H1 minus H4, and H4 is this, H1 is this.